Okay, let me try to explain the most general problem that is solvable by dynamic programming. So this is similar to the MILP problem that I described above, but it is more general. So we're still trying to find a permutation, which is an ordering of jobs. So let sigma be a function from 1 to j to the same set 1 to j. It's a rearrangement or permutation. Now, when you schedule this stage by stage, so let u sub j of sigma be the unscheduled jobs at stage j. Now at stage j, that means I've scheduled the first j jobs. That means I've chosen sigma of 1 through sigma of j. So uj of sigma is the remaining jobs that are not scheduled. So it's going to be the total set of jobs. Take out the set of jobs that are scheduled. So we're going to define a penalty function at stage j. Before, our penalty function was simply the late time, or how late the job was. But here we're going to define a more general penalty, which is some function of the jth scheduled job and the unscheduled jobs. All right, where fj is a real valued function. Now, if you think about it, this includes the previous situation as a special case. For example, I can get the completion time of the jth job because that depends on the unscheduled jobs. From the unscheduled jobs, I can deduce the jobs that have already been scheduled, and I can deduce the total duration of those jobs. So this sigma of j and unscheduled jobs gives me the information I would need to find the late time. So the late time is a special case of this kind of function, but this kind of function is more general. For example, it could be a nonlinear function, or if a certain job needs to be scheduled before job j, this penalty function could be very large if uj of sigma includes a job that should be scheduled before job j. So this is quite a general penalty function. What is not general about dynamic programming is that the completion times, say if you had completion times for the jobs, that would have to be fixed and not dependent on the order. Right? But this is quite a general penalty function. So there's a penalty at stage j, and that's given by little f of j. And there's a total penalty function, which is another function of these individual penalty functions at all stages. And this total penalty function must be an increasing function in each variable. Right? And our problem is to find a permutation that minimizes this total function of the that is a function of the penalties at each stage. Right. There may be more than one. Find at least one sigma that minimizes this function. So dynamic programming can solve this general problem. So as I mentioned, the question is this general problem of practical significance? So that's the issue. If this general problem is of practical significance, then it's worth finding an efficient dynamic programming method. Okay.